You are about to begin the study of the calculus, and my assumption is that for most of you this is the first time that you've undertaken a really serious study of this material. So I'm going to introduce you to the material and give you a sense of what it's like, what it's about, and why it exists as a field of mathematics. So the first thing that's really important to know is that calculus was invented or discovered 3 different times in history, by Archimedes and then both by Newton and by Leibniz. And that really gives you a sense that this must be really critical material, because 3 different people discovered the exact same techniques, attempting to solve virtually the very same problems. So what are these kinds of problems? What category or class of problems are these? And what is this material all about? Well, first, let me start with a problem that I think you're all familiar with. If you are trying to compute the average speed of a car between 2 points, or the average speed of a person walking between one point and another, you all had problems like that in high school, I'm certain, and you may even have a need to compute those kinds of average speeds in your daily life. And if I mention the formula, distance equals rate times time, I'm sure that for most of you that's very familiar. The problem that resulted in the need for new and more elegant mathematics is the need to compute the instantaneous speed or velocity of a car or a person at a particular point. That is, not the average speed over an interval, but at the very point that the person is at a particular spot, what is their instantaneous velocity? That computation, it turns out, requires some new, really very exciting and elegant mathematics, and that's what you're about to learn. A subsidiary problem, which turns out to be very related to the one I just described, is the need to be able to compute areas. And I don't mean areas of simple plane figures like triangles and rhombuses and even circles. I mean areas that you might find in the xy plane that are bounded by somewhat irregular curves. Those are much more complicated areas to find. And it turns out that the mathematics that's needed, we need to develop to be able to do those computations, is linked or meshed with the mathematics that is needed to compute instantaneous velocities. So what you're about to learn is this mathematics, this new, very exciting mathematics that will enable you to find instantaneous velocity and related issues, and very complicated areas of shapes and figures that are unlike the ones you've done in the past. I really am envious, in a sense, that you're about to begin this study, because it will change your view of what mathematics is and open up an entirely new world of mathematics and the applications mathematics can be used to solve. So enjoy it.